All right, I would like to welcome our next speaker, Hanoi Hantrakul. Hanoi, like the towers? No. Like the city? Yes. Hanoi's Thai parents fell in love there and nicknamed him after the charming city. Born and raised in Bangkok, Thailand, he's currently an AI resident with Google Brain. His research focuses on real-time neural audio synthesis, rendering sound directly using deep neural networks. Hanoi strives for technologies that are transcultural at heart, diversifying software, hardware, and AI to encompass underrepresented cultures such as those from his home region of Thailand and beyond. He's most proud of fidular, a modular fiddle system he designed and engineered that enables components like resonators and strings to be swapped across cultures. The system is currently on display at the Musical Instruments Museum in Phoenix, Arizona, and has been recognized internationally by the A Prime Design Award and Core 77 Design Award. Hanoi holds degrees in applied physics and music composition, both with distinction from Yale University. In his master's thesis at Georgia Tech, he developed machine learning models for an ultrasound sensor that enables amputees to perform high-dexterity tasks like playing piano, an impossible feat using today's sensors on conventional prosthetics. He also writes music under the moniker Yo Boy Hanoi. Find his tunes on Instagram and Spotify. Hanoi, please take it away.
Okay, that's working. Cool, that's starting. You guys can hear me? Great. I just have to sound check one more thing. Make sure sound is working from here. Okay, that's working. Cool, awesome. Let's start. I'm just gonna. All right, so hi everyone. Super excited to be here to talk to you guys about Magenta, but more broadly about machine learning and artificial intelligence and the exciting things that are going on in the world of creativity, in the world of art synthesis, in the world of music generation, that's all tied with a lot of the recent developments in machine learning and deep learning. So the work that I'm going to be showing you today represents the work of many from the Magenta group at Google. So just before we start, a little bit about me. Can anyone tell me which country that is? Anyone know? Thailand, yes. Okay, so I was born and raised in Bangkok, Thailand. And as you heard from my intro, I'm called Hanoi because my dad proposed to my mom there. And one of the things that I'm really interested in is sort of the intersection between how technology and music and traditional cultures all come together. Some of the work, I actually don't come from a machine learning background. This is actually something that's more recent and has been an opportunity that I've been able to pursue through the AI residency. Before joining the residency, the sorts of things that I was passionate about and the sorts of things that I worked on were things like building musical instruments that combine 3D printing with woodworking and enables you to change different resonators from different countries. So if you want like the snakeskin resonator from China, from the erhu, you can combine it with the strings from Thailand and things like that. In graduate school, I worked in a lab that designed prosthetics for musicians that have been handicapped through some form of accident. So this is Jason Barnes, and we designed not only a prosthetic arm for him to play the drums again, but here we have a system for playing piano. And then now I'm an AI resident with the Google AI residency program, and I've been working with Magenta for the last year, and I'll be showing you some of the cool stuff that's going on in the world of machine learning and music. So before we start, I kind of want to get to know you guys a little bit. So I have a couple of questions that will help me sort of triangulate how technical and how artistic my conversations are going to be in the next 30 minutes. So the first question I want to know is, how much do you guys know about music? So kind of read the options there. Raise your hand if you're in group A. Really? Wow, okay. Does that just mean you're just using other streaming services like Apple Music and things like that? Okay, I personally use Spotify. Cool. Put your hands up if you're in group B. Great, okay. And then put your hands up if you're in group C. Yes, we got some jazz people in the audience. Next question, how much do you guys know about machine learning and AI? How many of you are in group A? Okay, that's good to know. How many of you guys are in group B? Perfect. And how many of you guys are in group C? Okay, cool. That's actually good for me to know. How many of you guys are in group A? Group B? So this is any kind of artistic expression now. Dance, you can be drawing, okay? And then group C. No one, okay. Well, this is the Pi Data meetup, so I'd be surprised if there was professional musicians kind of swarming in. And lastly, how much do you guys know about Magenta? A? Great, and group B? Anyone? Okay, so we have a couple of people. And how many of you are actually in group C? Have you used some of our work? Oh, awesome, all right. Great, so to start off this talk, I want you to close your eyes, and I'm gonna play you a piece of music, and I want you to listen to this piece of music very, very carefully. I want you to think about the melody, I want you to think about the harmonies, I want you to think about expression and whether this is an expressive, creative piece of music. All right, you can open your eyes now. So what do you guys think? Pretty good. So what if I told you that that was actually generated by some of the models that we've been working with in the Magenta group? This is more of a jazzy piece of music. Let me play you some of the things that are a little bit more classical sounding. All right, so what is Magenta? So before we go into the details of how exactly that model works and the kind of training that we do and sort of the technical implementations, which which we'll definitely have time for and I can leave in the questions section, Magenta is an open source project at Google that's exploring the role of machine learning in the creative process. And the three main things that sort of define the work that we do is that we're interested in how machine learning can change the ways that we create, how it can augment human creativity, and we do this using generative models. So a little bit of a crash course on machine learning, just to make sure we're all on the same page. Most of you in here will know exactly what a function is. In this case, our function is just doubling a number. A function can also refer to graphs. So if you wanted to get directions from a particular point to another, your input could be one node and your output would be another node. Things get a little bit more complicated when your inputs are high-dimensional pieces of data, like images or video. And so in this case, it's a little bit harder to define what the explicit function is that transforms your input into your output. So machine learning is letting the algorithm figure out what these implicit rules are by drawing out those rules implicitly given a large database. And so what you do is, in the case of like an image classifier, What you need is like paired input and output, where if you given an image of a dog, the model just thinks that it's a cat, and you're able to correct the model and say, no, this is actually a dog. And then when it does make a correct decision, you're able to say that the function f is making the correct choice. And 1 million examples later, you can train a classifier that correctly classifies a dog as being a dog. And over the last couple of years, the accuracy in computer vision has grown at an amazing rate, thanks to deep learning, which is the use of deep neural networks and is an extension of some of these ideas that came from machine learning. And the reason that machine learning has gotten so good is because of our statistical methods, the fact that we have a lot more data available to us through the internet, and also because we have new hardware to do a lot of this computation on, from GPUs to TPUs. And a lot of people ask me, what's the difference between machine learning and AI? They're really the same thing. Artificial intelligence has been here since the 1950s, but each wave of AI has been characterized by a different set of statistical techniques, the most recent of which we are now using is under machine learning and deep learning. So those two things are sort of machine learning you can think of as a subset of AI. At Magenta, we are interested in a particular type of machine learning model, which are loosely called under the umbrella term of generative models. And so a language model is a very, very good example of a type of generative model. Here, the function gets an input of what word has already been said, and its job is to output what words needs to come next. So, for example, if you have a sentence, I am a, the model will take this as an input and output the next token in the sentence. And there's been a lot of very interesting and very exciting leaps in the world of machine-generated text. Here's an example of text that was generated by a recurrent neural network model in 2013. Notice that there's not really a lot, like there's words, but it doesn't really make any cohesive sense. Fast forward to 2019, if you give a machine learning a prompt, a shocking finding, scientists discovered a herd of unicorns living in a remote, previously unexplored valley in the Andes Mountains. Even more surprising to the researchers was the fact that the unicorns spoke perfect English. What you see here is now machine-generated text that's been trained on Wikipedia articles, and you can see that there's like a doctor who's an evolutionary biologist, and then they ventured further into the valley, and there's a lot more cohesion and long-term dependencies that the model is able to factor for. So now let's turn our attention to music. The same breakthroughs that we have in language modeling are also the same breakthroughs that enable us to model and understand music in ways that we couldn't do before. So what you heard earlier today is some of recent work by another AI resident who works in the Magenta team, Anna Huang, that uses what's called transformer models to generate the music. Let's compare this to some of the earlier pieces of music that was generated by our work from 2016. The difference is night and day, much in the same way the difference between the paragraph that I showed you from 2013 is with 2019. Oh. Cool. So you see that within 3 years, we were able to move from a single monophonic, not so sophisticated melody to entire pieces of jazz improvisations and classical music improvisations, thanks to these exciting advancements in machine learning. Let's skip these slides. OK, so the important thing to sort of take away from this little intro to machine learning is that what neural networks and what deep neural networks are very, very good at doing is taking this high-dimensional data, which is shown on the right as the data space, that is very complicated, and being able to compress this into what's called a latent space. And this latent space is what is learned when the machine learning model is being trained. And this latent space has a lot of useful information that the model has distilled about that high-dimensional data and enables us to do really, really exciting things in the case of self-driving cars. have cars that are able to learn from data. In the case of image recognition, do things like detecting cancer cells. But in the realm of music, actually enables us to do creative things that were never possible before. And what's been, how many of you guys got to play with the Bach doodle on Bach's birthday? Okay, cool. If you guys, just in the interest of time, I might skip over this, but the technology that powered that Bach doodle was a machine learning model that was trained on 300 Bach chorales. I highly recommend you guys go play with it. You just basically like push in little notes and it will harmonize that in the style of Bach. We've also been working with artists, and we have a very big collaboration. I'm very excited to work with different artists. So for Google I/O, recently we got to work with the Flaming Lips and also Claire from Yacht. And you can see some of our music and the collaboration that came out of that. We have hardware synthesizers, and the cool thing with this is we actually have a web demo. So, perfect. So some of the examples that I just showed you were examples where the machine learning model is generating notes. So it's not generating the sound. It's not generating the sound of a piano. It's not generating the sound of a guitar. It's just generating what note to play. It's like a language model that's generating what text needs to be written, but it's not doing this actual speech. It doesn't have the person's voice. It doesn't have the person's timbre. So we also, within Magenta, have research projects that look in the synthesis of the sound itself. And you can actually play with this. It's called NSynth, standing for Neural Synthesizer. And what this machine learning model has been trained on is about 300,000 sounds of different musical instruments. So we have trombones, we have harps, we have electric guitars, and what this model has learned to do is it's learned to distill the essential elements of what makes each instrument sound like that instrument. So what makes a piano sound like a piano, what makes a flute sound like a flute. And remember that latent space that I was talking about? Once you start embedding sounds in that latent space, you can do these crazy manipulations that were never possible before. So a very simple one, let's just take a harp and combine it with an electric guitar. You would get something that sounds like this. Pretty cool. So it has like the pluck of the harp, but it has like that crunchiness of an electric guitar. And the machine learning model learns to do this by itself. Now, what if we did something a little bit more creative? Let's take a cat meow and combine that with my favorite, a flute. Okay, so we got a flute, and we have a cat. So what you're gonna get is a cat flute that sounds like this. Like it actually sounds like a cat flute. Yeah. So it has sort of like the meow of a cat, but it has the pitch content and sort of the timbre of that. And so this is what this machine learning model is able to create these very non-conventional and very, very exciting interpolations between sounds that using traditional signal processing from electrical engineering would actually be very, very difficult to do. You would need to get a team of grad students to like hoard in a bunch of cats, like do a ton of recording on cat meows and things like that. But the machine learning model just does this naturally because of deep neural networks' ability to compress this very high dimensional, very complicated data space into this meaningful latent space. Cool. All right, back to the presentation. Oh, right, yes. So cat embedding, flute embedding, you get a cat flute. We can also do some other really exciting things. So instead of training a model on piano and then having it generate piano, we also have models that enable us to, given piano music, come up with music for the drums and a completely different set of instruments. And I'm going to show you this through a really exciting set of plugins that Magenta has released for Ableton Live. So for those of you musicians in the room, you can actually go and just download some of these plugins. So one of the core audiences for a lot of our work are people that don't necessarily know how to fire up a terminal and do pip install. So we also have wrapped a bunch of these models into user-intuitive interfaces and integrated them with music production software, this would be the equivalent of sort of wrapping image synthesis or image recognition models and having it directly available in Photoshop so that people can just click through and have the machine learning model do its thing. So without further ado, let's do some live demo on music. So here I have, this is what Ableton Live looks like. I've got like a piano sound here. Oh, the cat is still doing its thing. Let me just turn off the cat. There we go. All right, great. So I'm just gonna record like a little groove here. My timing is horrible. Cool. So I have a piano groove there, and what I'm going to do is I'm going to call up my trusty Drumify module, and I'm going to tell it to go to the piano, and I'm going to tell it to just use what I just generated. And the temperature basically just controls how actually, we'll see what temperature does. So I'm just going to click generate. It's generated here. Boom. And then I'm just going to move this to, so this is just, this track right here just has a bunch of drum sounds. So this track that it's just generated is a drum track. So let's see what it came up with. Pretty good. I'm just going to let that sink in a little bit. I just recorded live, just like a really nice like piano groove. Oh, cool, yeah, thanks. And then I fed it into this model that figured out like what I was playing in piano space, and then outputted a drum track, and then that's the drum track that you just heard. And we did this by actually, we gathered a data, we brought in a lot of professional drummers and actually recorded hours and hours of drumming, and we trained this model to basically generate all these different drums in different styles, and that data set is also open source. I'll show you where to get it in a second. Awesome, so this is actually a pretty cool drum track. I don't play drums, so this tool is like absolutely godsend to me. And what I'm gonna show you next is we're gonna come back to this session in a second. So a lot of our work is open sourced, and that's a really, really big part of sort of one of the founding tenets of Magenta. So we open source over 90% of the work that we do. When we publish a paper in a top-tier machine learning conference like ICML, we have a blog post that goes with it. We have Colab notebooks that go with it. It gets uploaded to the Magenta GitHub. We make a Magenta JS version. We make a Python version. We make plugins for you guys. And what's been really, really exciting, and this is all on our website, which I'll show you in a second, and what's been really exciting is that there's this beautiful explosion of user-generated contents that have taken the work that we've done when we open source our models, and people have built these really, really amazing demos, interfaces on top of our work, which you can see some of them here. And we also have Colab notebooks for you guys to use. So what I'm going to show you now is actually like a C++ application that I wrote before I came to join Google, and this is a right here. So what this is a, I know the user interface is like really sketch, but it does what it needs to do. So do you remember that little slider that we had with the cat where we could, oh, okay, doesn't matter. So this synthesizer here is basically using the same machine learning model that is interpolating between cat sounds, but I'm using it to interpolate between what are called wavetables. So I'm just going to record a little groove here. And what's going to happen now is you're going to hear the synth sound. And as I sort of change the interpolation, what the model is going to do in real time is sort of change these different waveforms, and you'll hear it as a change in the sound. I'm just going to make this a bit quieter. So this is built on top of some of the open source Magenta models. I'm going to show you another really cool thing that we can do. So we kind of have like our groove, we kind of have like our beat. So what I'm going to now do is I'm going to use another plugin that we have. And so I have a sound here. So I'm just going to record a little like counter melody. I'm actually going to turn this off. Okay, so that's very simple. And then I'm going to record another counter melody. So very different. One sounds like that. I actually don't really like that note. I'm going to change it. There we go. That sounds a lot better. Cool. So we got that, and we have this melody. So we have that. So what we have a plugin that can do is called interpolate. And what interpolate does is it takes one musical phrase and it takes another musical phrase, and then it basically creates all the gradations in between those two musical phrases. So what I'm going to tell it to do now is to take that sound which I just made, and then I'm going to choose clip 7 and clip 8. And then I'm going to say, like, give me 6 steps, and I'm going to hit like generate. Boom, so now it's generated these extra, so let's listen through them. So 1 out of 6 to 6 out of 6, 1 out of 6 is gonna sound the most like the first phrase that I put in. 6 out of 6 is gonna sound like the second phrase that I put in. So 3 out of 6 is gonna be like somewhere in between. So let's kind of have a listen to them. I have no idea what it's gonna sound like, so let's give it a go. Oh. And you know what? I have no idea what happened there. Oh, it's like very, very high. It's never done that before. So that's okay, because what I can do is just transpose everything up. We're just going to say plus 24 on everything. There we go. Actually, let's do plus 36. Okay, so let's listen to something in the middle. Yeah, I don't like that one. Let's try another one. Oh, I don't like that one. I don't like that one either. Okay, well, as you can see, sometimes it works, sometimes it doesn't work. Oh, you know what? I can tell you why it doesn't work. It's because it seems to. Let's see. Okay, maybe another day. Okay, so. Actually, this is pretty good. So what this shows you is that sometimes if you fall off the manifold of that latent space, then your machine learning model kind of generates like random sounding stuff. But sometimes if you're on the manifold, then it can generate some really interesting things. And this, I'm showing it to you in this form because this is actually how like a musician would use it. And so what we hope is that as you're playing with these different models, sometimes you land in sort of unexpected pockets of music that you wouldn't have otherwise generated. So I have about 5 minutes left. So what I wanted to show you guys was the Magenta website. So if you just type in Google Magenta, we have all of the work that we do located in this one spot. We publish very, very often to our blog. And so all of our different models and everything is all available here. And you even notice here with the drumming, we have the Groove MIDI data set, we have the Ableton Live plugin, we have the Python code, we have Magenta JS. All of it's located here. And in addition to that, if you play with some of our Colab notebooks, you can also connect to cloud instances on GCP that are running. You can do it right here, change runtime type. So you can take advantage of some of the GPU and TPU resources that Google Cloud has. And these are all freebie instances. So you can actually go ahead tonight and actually interact with some of our models and upload some of your own sounds, upload some of your own music, and see how some of our models interpret those from a more sort of coding perspective. And because I do want to leave room for questions. Sure that. There's another really, really good website, AI Experiments with Google. So we partner with another team located in the New York office called the Creative Lab. And so that really cool cat flute demo that I showed you, the interface and the design of that was done by some of our friends at the Creative Lab. And there are many more other experiments on this website that enable anyone, whether you're technically trained or non-technically trained, to have fun interacting with some of these machine learning models. And before I move on, I have one more piece of music to show you guys, and I want you guys to guess what question I'm going to ask you from this. All right, so show of hands, how many of you guys think that was generated by some of our machine learning models? No, okay. How many? Good, okay, because that's actually music from one of my albums on Spotify. Please go listen to it, thank you. Yeah, so if you're interested in more of this work, you have my email that's up there. And if you're interested and like some of the music that you heard today, I post a lot of my stuff on Instagram and also on Spotify. And thank you very much. I have the floor open for some questions.
All right, let's see those hands. I saw you first.
Also, I have prepared technical slides that I didn't go through, so if some of you have more technical questions, I'm happy to dive a little bit more in depth in those technical questions too.
Okay,
yes.
So it's really very exciting what you showed, and of course there are a lot of questions, I think. Maybe first question, can we hear something like sonata written in style of Mozart, Gain, or and this stuff because what I hear just pieces in specific style, but I didn't hear any kind of big kind of form of music, maybe symphony or whatever.
Yeah, so there's two really important things that you touched on. The first one is long-term dependency. So a symphony typically lasts, for several movements, 20, 30, sometimes a whole hour. And one of the limitations in a lot of generative modeling, not just in music, but in text, is that a lot of these machine learning models can't yet model long-form dependency. So you see that paragraph that I showed you at the very start, that Wikipedia article, that's about as far as it can go. 3 paragraphs is about as far as our best machine learning models can go. We cannot yet generate entire novels spanning 300 pages, and we can't yet do the same with long pieces of music. The second question, the second point that I wanted to talk about was style-dependent conditioning. And so you said oh, can I have something that sounds more like Mozart, but a little bit more like Brahms, with a little bit of Lady Gaga and maybe some Radiohead in it. So that kind of conditioning is also a limitation of current machine learning models, that we can't reliably generate high-dimensional data that correlates to this one piece of information that's being fed on the input side. And this is also true with text. Generate text that is happy with a tinge of sadness and a little bit of sarcasm, that's something that we can't do yet with our current methods.
Okay, so another question is about practical usage. Is it only for research, for enjoyment, or you expect some practical? Do you kind of expect next generation of digital piano will use this session partner like this one you mentioned, or like what's coming? Just interesting to know.
Yeah, that's a really great question. So the way that I like to see it is technology has always been intertwined with music, but also any kind of artistic expression. I'm just going to use music just because that's the domain that I'm in. But musical instruments really are a form of human technology. If you think about like all the way back, human beings started to carve flutes from bones of animals. When the shipbuilding and metal building industries popped up, for example, in New Orleans, that was the same technology that enabled us to build trumpets and to build trombones and all these brass instruments. Then when electrification came along and electrical engineering hit its boom, we had electrified instruments, and that was when the electric guitar was made. And then when computer science came along, we had a whole revolution in how we record, distribute music, and also generate and synthesize music. A lot of pop music, for example, now uses synthesized sounds, and it's become completely normal in music. So the way that I like to think about it, and paraphrasing some of the other views in the Magenta group, is that we really see machine learning and AI as sort of this next step in this sequence of technologies that are being invented. And so we're not interested in how we can, replace the musician, but think about more like how can we invent the next electric guitar? Like what does the ML-powered guitar or like the ML-powered instrument look like, and what kinds of new forms of music or new forms of artistic expression that kind of combination would enable.
So I've gone on your website and I've noticed that there are like a lot of just a long list of like different blog posts and like little demos and little apps and utilities, but just from looking on the website, like navigating through it, it feels like it's hard to like get a grasp of like the full range of, I guess, capabilities that Magenta offers at this point. Like it's hard to get a comprehensive list or I guess a structure, just from reading the blog.
Yeah, cool. That's really good. That's really good input. I'll be sure to bring that up like in our next group meeting and talk to the person who like designs our website. So Magenta is a very new group. It was formed in 2016. That's actually when I started grad school, and the whole reason I'm into machine learning is because I saw like Magenta's website and became really inspired to pursue this field. A lot of the work that we've been doing has been, these sequential works that we just sort of like post and post and post and post. So maybe kind of like a welcome page that kind of puts into a tree. That's really good feedback. Thank you. I appreciate that.
Hi, great presentation.
Thank you.
Yeah. Do you know any musicians that we might all know that are using this for their work?
Yeah, so Flaming Lips is, so I didn't know the Flaming Lips. Apparently it's a generation before me, but I was told that the Flaming Lips are really, really famous. There are some, I guess you're asking this question because you don't know Yacht and Flaming Lips. So there are some other musicians that are using this technology, but it's still very, 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 very small. A lot of this has just been the availability of a lot of these technologies are still limited to more technical folks. So the answer to that question is actually not a lot yet. Yeah, yet. So we hope that with tools like Magenta Studio being integrated in professional music production software, that there will be more musicians that use that. I actually use a bunch of stuff in my music too, if you want to go and listen, but I'm not that famous yet.
So previously we've been relying a lot on like music theory and both just to study composition, but also like for algorithmic composition. Do you feel like that's just totally gone by the wayside with these generative models? Do you feel like that there's interplay between understanding of music theory, or I just want to speak more about that?
Yeah. So algorithmic composition, for those of you who are unfamiliar, so this is not the first time that computer scientists and people that work in computer science have been interested in using some of these algorithmic tools to describe and to generate music. This is something that has actually been around since computers were invented. And algorithmic composition is basically a subset that intersects computer science with music, where you write like pieces of code and pieces of instruction, much like you would with an application, but those instructions are actually for composing music. So I think that these are very, very complementary approaches. I don't think they occupy the same space because I think that there's a lot of things that algorithmic composition that, that kind of when you're writing code and you're giving these instructions, that creates a very unique kind of sound and speaks to a community of listeners and musicians that's very, very different to sort of some of the music that's being generated by our model. So I actually see them as sort of complementary tools. It's like another musical, another musical instrument in your toolbox that you can use in addition to some of these newer tools that we're researching.
Could you explain why the generative models can only go for so long? Is it like a physical limit, or does just the quality go down so much that you don't want it?
So there's a couple of reasons why. So actually, this is a good point to show you one of the technical slides. So before, the way that we encoded in, how many of you guys know what a recurrent neural network is? Okay, so usually if you want to model sequential data, you use a recurrent neural network. Some of the big breakthroughs in machine translation and also the music work that we do is we now actually don't use recurrent neural networks to model it. We use what's called a transformer model, which actually cuts those recurrent connections and is all convolutional based. So to answer that question, number one is the type of architecture that we use is a limitation to that. And we've sort of broken a ceiling by switching to this transformer model, but there's also limitation, like that sort of extended the amount of cohesion that this model has to like several paragraphs or several minutes of music. But this approach, we have yet to invent like the model that would enable us to do like entire 100 pages or something like that. So the first one is an architecture choice. The second one is representation, how you actually encode the information. So previously people would do things like they would just say like what note was being played and then have the model like output what note comes next. We have at Magenta like a little bit more of a sophisticated way of encoding music that has like shifts in milliseconds, and then the model outputs like the shift of like the next note so that it sounds more like a human playing. And this was something that enabled us to generate music that sounded a lot more expressive and a lot more long term. So there's an encoding and there's an architecture sort of limitation, and we have yet to sort of figure out what the next breakthrough is to get it working long form.
So the architecture has kind of a numerical limit. You set the size, and then that's going to determine the length of.
Yeah, it's not just about the size, but it's like the topology of the network, how much, the way that we set up all the neurons to connect with each other, and how how many layers and things like that. There's a fundamental limit to how much information can be compressed into the latent space, and that's all dependent on like what is how the encoding topology is trying to encode all of that information. So it's not just sort of like a sort of a limit of like how much you can have the same number of parameters, but a more efficient encoding if it's designed better.
So it's not obvious what the limit is beforehand.
Exactly.
Yeah.
Yes. Yeah. Precisely.
So you showed us like a couple of pieces of music. One of them was from 2016, and one of the first examples you showed us was very recent. Mm-hmm. And for example, I personally like the one from 2016 more, which might be very counterintuitive for a lot of people. So my question is, what's some sort of objective measure that you use to actually see that you are improving over time? Yeah,
that's a really great question. So the question is about what is an objective measure when you're doing something with music? Well, it's very easy to come up with a loss function that's based on how good music sounds. No, it's not. It's actually very, 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 very difficult to quantify what good music is. And that's also a very culturally dependent definition too, because as you'll notice, a lot of our data sets are highly skewed towards Western music, jazz and classical music, which has its own definitions of what beautiful music is. If we now have musics from other parts of the world that have different tuning systems, that have completely different scales, that have completely different notions of harmonies. I play a lot of traditional Thai instruments. Like we have 7 notes in the scale and don't have like major or minor keys. Under some of these definitions, some of these models would say that Thai music just completely sounds out of tune. So we have 2 ways of approaching this. The qualitative way is we do listening studies. So we have people like listen to music that's being generated by our models, and we have a bunch of questions that ask them that rate like how expressive is this music, how complex is this music, did you think this music was written by a human being? If so, what level musician were they? Things like that. For more quantitative measures, you can measure things like log likelihood of the data. So this is just measuring how well the model is predicting, information that comes next in a sequence. And as long as you sort of minimize or maximize some of these more quantitative like probabilities, that's sort of like a quantitative proxy to a model that is able to produce like good music, meaning it's close to the distribution that it came from.
More questions.
This is great. It's like so many questions.
Hey, thanks again for the talk. This was really cool to see like more applications of machine learning. So I'm like more on the musically deaf side. So can I go and use Project Magenta even though I won't like understand those plugins? And following that, will I become a producer?
Yeah, so that's a great question. So I think that there are things that machine learning, so the really exciting thing about combining machine learning with music is that I think it has the potential to change how musicians, whether you're a novice or like a really, really seasoned musician, interact and create music. And there are specific things that would enable like a novice to do that they wouldn't know how to do by themselves, but there's also other things that are like maybe a little bit more limited. So a really good example, actually let's kind of play around with, is the Bach doodle. So actually, as I fire this up, this will answer your question. I can actually take the next question while we're letting this load.
Who's next?
Okay, actually, do you want to come on stage? And like, yeah. Trust me, it's really fun. Skip intro. Okay, so what you're gonna do is you're going to like input like a bunch of notes here. You can do whatever you want. Okay, so you're just gonna. No, that's the whole point. That's the whole point. So like you could literally just close your eyes right now and then just like put a bunch of notes and then click harmonize, and then this machine learning model will try its best to make you sound like Bach, no matter what. Really? Okay, cool. So we'll let you do that. I can take the next question. What's your name, by the way?
Michael.
Michael? Hanoi, nice to meet you. All right, so while Michael inputs his amazing composition, I'll take the next question.
Yeah, so this is, I guess, a little bit less about the Project Magenta in general, but more about generative models and like creativity. Mm-hmm. So I could understand how creating text and composing text and even like visual art and music, how you transcribe the encodings to put into a generative
Click
model.
harmonize immediately.
I'm wondering, I'm a dancer myself.
Yeah.
I'm wondering if anything like that has been done for the field of movement.
Yes, there has been a lot of things that have been done in the field of movement. So we have a machine learning model that's called PoseNet. Maybe let's just, oh no, but you actually want to hear what you're saying. So we have a machine learning model called PoseNet, which so back in the day, if you wanted to do full body tracking, you would either need a body tracking suit or you would need like a Microsoft Kinect. We can now actually take the skeleton, extract sort of where your joints are using just your webcam input. And with this, there's been, I don't know if I can find it, but I can search for it. The Creative Lab and also Google Arts and Culture Lab have had a whole project where we've taken professional dancers and we've recorded sort of their skeletal movements and then have the model actually generate some of these movements and have the dancers sort of follow and interpret some of these dances. So yes, and also we have video synthesis. So we can actually synthesize videos of dancers like dancing. It's kind of trippy and kind of gnarly, but it's a very, very fascinating intersection in the world of movement. Okay, cool, Michael. So this is your masterpiece. Let's kind of have a listen to it. Okay, so what we're now gonna do, so I want you to hit harmonize. So just harmonize, just click harmonize. Okay, and this is what the machine learning model came up with. wrote you just wrote a Bach composition. All right, thank you, Michael. Yeah. All right, so that's the Bach doodle. So you guys got to see the Bach doodle. So imagine this being extended to other genres of music. So let's say you're interested in jazz, but you don't know how to write jazz. So you give a melody to a jazz model, and it makes it jazz. Or you're interested in music from South India, or you're interested in music from Thailand, where I'm from, and we have models that have been trained on these different genres of music. We could potentially enable people that don't know how to write in that style to be able to write music in that style. So that answers that question.
Okay, so
last one.
Okay, so like pretty much just comment about this example. So it looks to me it's just a general exercise when of classes for harmony.
Yeah.
I do not see too much of Bach here because it's most known to write polyphonic composition like fuga and this stuff. So it's maybe too complicated to get really fuga out of this. Just observation. So like also there is another part of creation of music is interpretation. So I didn't hear anything about this part, but even if you compose a piece, it's also about question how to interpret, particularly to play it, because you know, like you can play the same written music, even like this one, in many different ways. So you understand what I'm saying?
Yeah, of course. So yes.
So like, do you work anything on this? And last question about like any kind of predictions, what you expect in the next couple years, 5, 10 maybe, and what we should expect out of this technology.
Yeah, sure. Okay, I'll try to touch on those as quickly as I can because I know we're out of time. The thing being on interpretation is we're now talking about a sheet of music that has been written and you have a performer that comes to interpret it. The work that we're doing is not about given a piece of music, how to perform it. We're interested in the sort of the generation of the music itself. So in terms of like how pianist A plays it and pianist B plays it and pianist C plays it, pianist D plays it, we encode all of that in the generation side. So for example, if we're generating piano music, the model tries to do these like little shifts in timings or add notes that usually, like if you did another run, for example, it wouldn't do that kind of generation. But in terms of like performing, not really. And the last thing, so I think definitely in the next couple of years, you're going to see more of these models being integrated into professional music tools. So Magenta Studio is like a step in that direction. But expect to see, in Photoshop, for example, using GANs and using generative adversarial networks and having it like actually integrated into the software itself and allowing you to do things like you just draw a tree and then it actually renders a tree, or you draw a couple of gestures and then it will render music that follows some of those gestures. I think that that's what we'll see in the next like 5 years. 20 years from now, I'm actually not too sure. Like we might have a whole different new sets of statistical techniques that enable us to do things that current machine learning model could never do. But those are the things that like I'm most excited about. Yeah.
All right, let's give Hanoi another round of applause.
Thank you.
That's all we got. Thank you for coming out. We have the space until 9, so hopefully you can continue some of those conversations you started at the beginning or come ask Hanoi some more questions live. And hope to see you again next time.
And guys, give a big hand to George over here who organized that thing, and his gorgeous wife Katrina, she's running around over there, and Josh for recording, and everybody for you for coming. So thanks a lot. Give them a big hand again.